so we'll wait for 2 more minutes and then we'll start. Yes, so is my screen visible to everyone? Can anyone confirm, is my screen visible and am I audible?
No, sir.
My screen is not visible.
not visible. No, sir. Not.
Is my screen visible, right? Hello? Yes. Okay. So, so tell me, I had sent a mail regarding the download of Anaconda software and installation. So, could you install the software? I need everyone to install the software because we will go side by side. So, I'll also run the code and you will also run the code. And when you face some issue, then you can also share your screen and I'll see if I could help you with solving that issue. I want everyone to download the software and install it. So, has everyone done it? You can unmute yourself and speak because this is very important. Otherwise, you will not be able to follow what I am doing. Yes, Pratibha?
Yes, sir. I've installed it.
Okay, so are you able to open Anaconda?
Yes, sir.
Okay, and others? What about others? All right, Ranjit. So you should speak out, otherwise I'll just do what I am doing and you will not be able to follow. You should have installed Jupyter in your system, or I'll show you the Google Colab how it works. Yes, you are not audible. See, unless and until you speak, I'll not be able to know. You can give a thumbs up also, otherwise, if you're not able to unmute yourself. All right, Ram Prakash. So I guess I don't know if other participants are there in the meeting or not. So first we will see this Anaconda. So how do we open Anaconda? So this is a Mac. You can do the same thing in your uh, Windows as well. So when you first open and so if you have installed Anaconda, you can just search in your search bar in the bottommost corner Jupyter. When you write Jupyter and you press enter, this page will open. And if you are having a system, you should open this right now and follow with me. All right. So you should see the screen. So this screen will show you all the folders which are there in C drive. Alright, it will not show you any other drive, because if you have installed Anaconda in your C drive, then it will show you the files in C drive only. So this is my C drive. Alright, so you can go to any folder. So I am going to documents, and you will have to make a new folder. So over here you see there is new, and you can click a folder. So when you click a folder, there will be one untitled folder. Please follow along. You should do along with me. Alright. So you can rename this folder by clicking here and write rename, and you can write it anything, or Python programming or anything which you want. I have already created one folder, so I'm not doing it. I'll just delete it. Alright. So I have created a folder, and ignore these two files. Alright. So you can create a IPNB file here. Alright. So over here you click new and Python 3. When you create a Python 3, so if you go back, you will see there is one untitled file, untitled.ipynb file. You can rename it over here also. You can rename it. No, you can rename it from here. So from here you can go and you can rename it as lecture 2. Alright, or anything you want. It is your wish. And you will able to see these files in your system if you go back in your file explorer, and when you go to documents and the folder which you have named, then you will be able to see this file there. But you can only open this using Jupyter. All right, so you see this is the interactive environment where you can run Python commands. Over here you will see a cell. This is called a cell, and if you go to cells, you can see that you can run a cell. This run is actually, if you are in Windows, you will see the shortcut. The shortcut for run is actually a command, not command. If you are in the Windows, it will be Ctrl+Enter, run cell and select below, it will be Shift+Enter, run cell and insert below will be Alt+Enter. So what it means is, if you write here 2 plus 2, it is just, Python is just like a calculator, you can say. So if you enter, if you press Ctrl+Enter, it will execute the cell and it will stay in the same cell. You see there is an output written. All right. So this you will get. Try and see if you are getting this. If you are getting this, that it means you have installed correctly. All right. Please confirm if everybody can do this. All right.
Hello, Vijay.
Yes, yes.
Is your screen is lagging or kind of something? Or
can
I want to
anybody
confirm. Yeah.
Yes. Is my screen laggy?
No, for me it's okay.
Okay, so Rajiv, I guess some internet issue might be there at your end.
Okay, I'll rejoin it. Okay, wait.
Okay. So I have pressed Ctrl+Enter. When you press Shift+Enter, then what it will happen? The cell which was there, it will get executed, and you will go to the next cell. Now, if you press Alt+Enter, when you press Alt+Enter, then that cell will be executed, but one cell will be inserted below the cell. All right. So I hope you can do this. This is not very difficult to understand. All right. Now there are few more commands. So suppose I have a few more things. 3 into 2. I'll just execute few of them. 4 into 6. Something like that. And I will see. Now these numbers 3, 4, 5. This tells us the execution order. So I have executed this in the third step, this in the fourth step, this in the fifth step. If you go back to this and run again, if I press Shift+Enter, then it will become 6. So I have executed this fourth, fifth, and then sixth. So this number tells the execution order. All right. Now you see, when I am in this line number 4, I shouldn't tell it as line number 4 because I have executed in fourth step. If I execute it again, the number will change, but still I'm calling it line number 4. And if you run all above, so everything above it will be executed. So you see 7, it is executed. This was 6, it became 7. Now similarly, if you are here and you run all below, so everything below that cell will be executed. So you see 8 and 9. All right. So this is how you run a cell. Now you can also type here. So why we are using this instead of other Python software like Spider or any other VS Code or something like that, because this has some interactive features. So you can write something. So if you press a cell here and go to cell, and you can go to cell types. So you can write a code like we are writing 6 into 4 into 6, 2 into 3, something like that. You can also make it a markdown cell. So when you make this a markdown cell, you can make this a markdown cell by going here and selecting this. There are three ways to actually make a markdown cell. All right, so I will say this is a markdown cell and I'll write something. Suppose I am writing a markdown cell, markdown cell. So you see it is just a text. Now another way to make a cell as a markdown cell, as you can go here and you can do markdown cell. So it will become a markdown cell again. Markdown cell. All right. Now one more way is to make a markdown cell is when you click over here, see my cursor, this cell will become blue, and when you press M, then it will become a markdown cell. All right. Now in markdown cells, you can do few more things. You can make a heading. So if you press hash space, it will become a heading. All right. If you do double hash, then the size will increase, or it will become second subheadings, subheading, 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 or something like that. All right. So these are some of the features of a markdown cell. There should be a space. Yes. Now you can add a cell. When you click here, you see the cell turns green. This is a code cell. You can write a code here, but if you want to insert a cell above or below, so you have to press this side. You see the cursor, it will become blue. If you press A, then a cell will be inserted above the cell. So suppose I am writing 4 here. So you see I am pressing A. So one cell will be inserted above that cell. And when you press B, then one cell will be inserted below that cell. All right. So everybody is able to do this. Please confirm.
Yes.
Yes, sir.
All right. Yes. Okay. So these are few of the features. Now, if you want to convert a markdown cell back to a command cell, you have to press Y. So you see I am in a markdown cell, and when you press Y, it will become a command cell. All right. And if you again press M, it will become a markdown cell. All right. And when you run execute, then it will run. All right. So these are some of the features of the cell. Now I'm coming to kernel. So what is a kernel? You can think kernel as a mini computer. So this is where the execution of this IPYNB notebook is happening. All right. So sometimes you may encounter a infinite loop. Suppose you have written a wrong command, sorry, not command, program, in which the loop is running infinitely, and you want to stop the execution of that loop. If you press double I, or you can come here also, you can come here and you can interrupt that kernel. When you interrupt that kernel, the execution of the code will stop. You can also restart the kernel, so it will stop and start again. You can restart and clear all outputs. So what it happens, you see I have some outputs, 4, 6, 24, these are all outputs. All right. So when you click here and you see restart and clear all outputs, so it restarts and clear all outputs. It doesn't run anything. So you see when I restarts and clear all outputs, everything becomes blank. Nothing has run. Instead, when you run restart and run all, so it restarts the kernel. So it shuts down the kernel. It's like switching off the phone. It shuts down the kernel and runs all the cells. So when I press this, it will give it will confirm. And when you confirm it, so it will run all the cells. You see 1, 2, 3. And why nothing is coming here? Because there is no entry in this cell. That's why number is not coming. So it is 4. If you go back here and suppose you are running this again, Shift+Enter, so it will become 5. So these numbers are nothing. These are not positions. These are the order in which the cell is being run. All right. So I have told you what is a kernel. I have told you cell. Insert, I have told you how to insert a cell above and below. View is not important. Edit is important. You can cut, copy, paste and delete a cell. So these are some of the shortcuts. So if you press double D, over here, suppose clicking this side. So when it turns blue, then only you can do these shortcuts. So if you press double D, it will delete that cell. All right. You can undo that cell by pressing Z. So when I undo it, so it will come back. Now in edit, there's split cell. So what is split cell? These are not very important, but I am here, so I should tell you. So suppose there are two, three instructions are written, or code is written. So 4 plus 2, 4 plus 5, and 5 into 2, something like that, right? And you want to split it, so you have to be there, press an enter, and you can split the cell, so it will be splitted. Now one thing I have to mention here, so this output is not actually printing anything. You see, when you generally run a program and when you get something in the screen or printing something in the screen, this is not the same as this output. This output is just a peek. You are just peeking inside what is happening in the cell. So you see, when I run this 4 number cell, so it is not a 4 number cell, but still I'm telling it as a 4 number cell. So you see, when you run this, you're only getting the output of the last line and not the line before it. This is because when you run this command in Python, you will not get any output. These are not outputs. These are just sneak peek inside the last line of what is being executed. All right. So, but if you want to print these two separately, then you have to write print. When you write print command or print function actually, then you will get the output of both. All right. Then you see, you will get 9 and 10 and you're not getting an output cell. So this is suggesting that this is not the output as in this IPNB file. When you run this as a .py file, so what is a .py file? I am coming to it. So when you run this as a .py file, you will get this output in your screen. So what is a .ipy file? Generally, Python executioner or interpreters run .py files. So you see, when you go to files and when you see, you can download it as a .py file. So suppose you have a code written here and you want to download and run it in some other program. So you can download it as a .py file. Instead, you can also download it as a notebook as .pynb file. All right. You can also download it as a PDF, but I would suggest you should go to print preview and then you should save as PDF. All right. It is better that way. So where was that file? This was that file. Yes. Anything else? You can you can create a which thing you want me to repeat?
Sir, file format that py.
Yes. So see, this is actually interactive environment. All right. So in this interactive environment, this file format is actually .ipynb file. You can see here where you have saved it, you will see that these are .ipynb files. In the background, these are running Python, but these are interactive environments, so these file formats are different. All right. But if you want to download it as a Python file where you can run using your command line interface, if you know what I mean, then you can download it as a .py file and directly run from your command line or command prompt. All right. So this is the general format in which you will get a Python file, .py file.
Okay, sir.
I hope I am clear.
Yes, sir, clear.
Okay. So make a copy. So if you want to make a copy, you will click here and this file will be copied and you will get lecture2.copy. And when you go back in your files, you will see lecture2.copy is there and you can delete it. Since I don't want it, I am deleting it. So I am deleting it. It's confirming. Yes. You can always create a new file. You can go to new and create a new notebook, Python 3. So this is a new notebook. Oh, okay. This is deleted. So let me, yeah. Make a copy, save. One more thing, this is automatically saved. So whenever you save, it will say 13 minutes ago and one checkpoint will be created. You see, revert to checkpoint. So whenever you create, there will be, and you save, one checkpoint will be created and you can go back to your last saved checkpoint. All right. And I don't think nothing else is here. Yeah, everything is done. And I will show you Google Colab also. If somebody is running Google Colab, you see this Jupyter and Anaconda takes some time to open. So I would suggest in every class you should open this Jupyter before you join the class, because it may take some time depending upon your system. All right. And if you don't want to install this, because this is a very heavy software, you can always go in the cloud and do the same thing which we are doing. There may be slight changes in the command of run. So there may not be Shift Enter to execute the cell and go to the bottom cell. These commands may change, but everything else will remain the same. So this is, so you can just search Google Colab, 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 and you will find this colab.google. When you click this, you will come to this interface and you can just go to Open Colab. When you go to Open Colab, you will see the same environment. All right. So it is asking you to make a new file. So you can just create a new notebook, and this notebook will be created in your Google Drive. All right. So I have some files here. So I'll click one file. Untitled file is there. I guess some time back I must have made it, and it is empty. All right. So you see, you can do the same thing here. It will take a little bit of time to execute the first command. Once it executes the first command, then other command will be executed relatively faster. So this is one drawback of using Google Colab. Otherwise everything is same. So whatever is here will be same as Jupyter Notebook, but I'll be using Jupyter Notebook, so it will be better if you use Jupyter Notebook such that you can match. So you see it is a text here, it's not written Markdown file, so it is same, it will become a text here. So if you do one hash and then you write some title, TITL, and you run, so it becomes a title. It is same as what I have been speaking for some time now. All right, and you see I have run one command. Now if you run another command, it will not take as much time as it took in the first command because it was connecting. So since it is connected, so it will run as it is. Now you see the since this is using your Google Drive, so you can access some files from Google Drive as well, but here is a runtime files. You can keep the files here for the runtime. So you can upload a file here. Suppose you are accessing some Excel sheet or some CSV files to run in your code. So you can upload a file here, but remember one thing, once you cut this environment, or once you close this tab, this file will be lost. So you have to keep a copy of that file, or you can keep it in your drive and then access it, but it is a little bit cumbersome. All right. So it is better to just upload and do whatever you want and then download the files. And this is why I recommend using Anaconda, because everything will be in your system. All right. Any questions?
No.
All right. Just 1 minute. All right. So I see 15 participants here. So could you please confirm that everybody has downloaded Anaconda and can run Jupyter? If not, then please go to Google Colab and use for today, because it is important you follow along. Otherwise, it may be difficult for you to follow afterwards. All right. So can you confirm that you can access the chats or not? I guess you may not be able to access the chat. Are you able to access the chat here?
No.
All right. So yeah, this is done. Now I'll proceed for today's class. So you see, Python is just like a calculator. So you can use it like a calculator, like 2 plus 2, I have got an output as 4, 3 into 2, I have got an output as 6. This will not be a case if you run this same command in Java or C++ or any other language. This is because Python has been built in such a way. All right. And moreover, Python is a high level language, and everything. So if you run in Python or in Java, all will be converted to a low level language or a more machine language like C. And then the interpreter actually converts it to machine level language, which is 0 and 1, and then executes it. All right, so this is just I wanted to say. Now I can proceed with today's lecture. So today is the second lecture, and I am Shubham Keshri, PhD scholar in the Department of Management Studies, IIT Kanpur. All right, so today we will have an introduction on Python. And I hope you could access the course website. I have uploaded the PDF and yesterday's recording in that website, and explore that website. It is a good website. I can also post some assignments or assessments in that website, and you can submit there itself. Otherwise I'll have the trouble to make a Google form and take submissions. So please, once when you get time, go to that website and see if you can access, and everything is fine. All right, so let's begin. So first we will see some aspects of language, and then we'll move on to see not what objects are. We will not go deep in what objects are. We will see some objects which Python uses, and we will see some features of those objects. We will not dwell deep today on what objects are. All right. So first we'll see the aspects of language. So you see there are three things when it comes to language. First is syntax. What is syntax? Syntax refers to the set of rules that govern the structure of the language, ensuring meaningful communication. So you see, if you take an example in English and you say Paul, cat, dog, three nouns are there, noun, 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 and this is not a correct English syntax. There should be some verb or something like that in this sentence. So if you say Paul kisses dog, then this is syntactically correct. This is a correct syntax in English language. Similar to this, Python also has some syntax. So you should write in correct syntax. Otherwise, Python will have difficulty understanding what you are saying. So your code should be syntactically correct. For example, if you write 8.6 plus 3.2, this is correct syntax. Whereas if you write 32 and hello, this is not correct syntax. So in Python, so what is this? This is an operand, this is an operator, and this is an operand. So operand, operator, operand is a correct syntax in Python, whereas operand, operand is not a correct syntax in operator. So this is also an operand, 32, and this hello is also an operand. Sorry. So operator, operand, operator is a correct syntax in Python. So you should know the syntax of any language before you start writing that language. Similar to how you know the correct syntax in English before you, not English, in any language. If you don't know the correct syntax in that language, you will not be able to communicate in that language. So similar to that, in Python also you should, not in Python, in any programming language also, you should write correct syntax. So this is a way to write a correct syntax: operator, operand, and operator. Sorry, operand, operator, and operand. So I have not listed down all the syntax. You may find it in Python documentation, or after the class, if I find something, I'll upload it. But this is just about syntax. Now, if you go to the second aspect of language, that is static semantic. What is static semantic? You see, static semantic says that it should be meaningful. Whatever you are writing should be meaningful. So it says that static semantics verifies whether syntactically correct statements contain meaning or errors. So I know this is very difficult to understand what it is saying, but an example will clarify it. So suppose in English you are saying the sky is green, or you are saying cat barks loudly. So you see, these are correct syntactically in English. These are correct syntax. So this is a noun, this is a verb, and this is an adjective. So this is correct syntax in English, but it doesn't make sense. These are not meaningful sentence. Cat cannot bark. The sky is never green. So this is what static semantic means. It should make sense. All right. So in programming, every sentence or every code should make sense. It should be syntactically correct, and it also should be static semantically correct. So you see 10 divided by 5, but this 5 is not numeric 5. It is actually a string. So what is string, will come to that. But 10 divided by 5 is a static semantic error. So you see, this is correct in a sense of syntax. So this is the correct syntax. Operator, not operator, operand, operator, operand. So this is correct when it comes to syntax, but it is not making sense. So it is static semantically wrong. I hope you are understanding. If you have any doubt, you can stop me. Don't let me just move on. So you're making sense, right?
Yes.
Don't go into these terms. These terms, what it means is more important. So these terms may be confusing, and you may not require this in your future coding work, but you should know what it means. All right. So you should write a sentence which is correct syntactically as well as static semantically. All right. So what is the importance? Understanding static semantic ensures that statements are not only syntactically correct but also meaningful, because it is important to be meaningful. Otherwise, it will not make sense. You will just say gibberish. All right. Now another thing is semantics. So you see, this was static semantics, and this is semantics. What is semantics? Semantics says that. So first, let me read it. It says that semantics refers to the meaning associated with the statement or code. It's essential to have clear and unambiguous meaning in programming to avoid confusion. So whatever you are writing should have unambiguous meaning. So it should be clear. It should not have any ambiguity. So suppose in English I am saying that I saw a man with the telescope. So I apologize, I have given wrong inverted commas here. Previously also I have corrected it. So I have given wrong inverted commas here. All right. So when I say I saw the man with the telescope, this sentence has two meanings. You see, it means that I saw a man through my telescope. I was using my telescope and I saw a man. And the other meaning it can convey is that I saw a man who was using the telescope. So please read and see if these two meanings are clear to you. Are you getting it?
Yes, sir.
Yes.
Yes. So this English sentence has two meanings. So such ambiguity is acceptable in English language or any other natural language, but is problematic in programming languages. What will happen is you are trying to do something, but the computer will think something else and will execute as per their interpretation of the code. So this is not correct way in coding. You should write exactly what you want, because the computer is actually you can say foolish. He or she doesn't know what to do. Whatever you tell him to do, it will do that. It will not do anything on their own. They don't have that neural power. All right. I'm not using correct language because I should not say neural power. There is some technical term with neural. But you get it. All right. So one example I have given in Python. Suppose you are saying 5 divided by 2. All right, you see 5 divided by 2 can be two things. It can either be 2.5, or you are thinking of only getting the integer part, which is 2, not 2.5. I know some of you might think that 5 divided by 2 will give 2.5, but in your mind it may be that you thought 5 divided by 2 will only give you the integer 2 and not 2.5. If that is the case, then the computer will execute and whatever it thinks correct and give you a solution which might not be in line of what you wanted. So you see 5 divided by 2 may be written as 5.0 by 2, which will yield 2.5, or 5 divided by 2. So what does this mean? You come to a code and then we will see. Just a minute. When we go here, I'm writing here and then you see 5 by 2. And when I execute it, it will give me 2.5. But when I do 5 by double divided by 2, then it will give me only the integer part. It will not give me whatever is behind the decimal point. And mind you, it is not rounding off, it is just truncating. So if you have something like 10 by 9. So 10 by 9 should be 0 point some 99 something like that. So it is sorry 10 divided by 9 is not, I want 10 by 11. So 10 by 11 is 0 0.99909090. But when you write 10 double divide by 11, so it will give you 0 and not 1. So it is not rounding off. It is just truncating the part after decimal point. So someone was unmute. So do you want to ask some question? All right. So we'll proceed. So this is what semantics means and what is the significance. So the significance is, in programming, clear and unambiguous semantics are essential as computers relies on precise instruction. Ambiguity can lead to error and unexpected results. All right. So in language, we have talked about three things. The first is syntax error or syntactic errors. So generally, when you write a code which is syntactically incorrect, so let me give one example. All right. So suppose you are writing 32 and you are writing two operators together, 32 and hello. So you see, when you execute this code, it will say syntax error. So this syntax error are easy to detect. It is easily detected, but it should be addressed before you want to execute the code and get a solution. All right. So it is essential you don't make a syntax error. All right. Next is static semantic error. So these errors are also such that it will be detected by the computer. You see, when I write a syntactically wrong command, suppose I am writing 10 by 5. So it is not saying syntax errors because this is syntactically correct. Operand, operator, operand. But this is not static semantically correct. All right. This is the most dangerous errors, semantic errors. So semantic errors are such that the computer will not be able to find. And if you do semantic errors, then you will get unexpected solutions. So you may get some unexpected outcomes. You may also, the program may crash or stop. Moreover, you may get stuck in an infinite loop. So getting stuck in an infinite loop when you were not intending to get stuck in an infinite loop is an example of semantic errors. All right. So is this clear?
Yes, sir.
All right. So there are a lot of people here, 15 people. So I guess whoever is not able to understand should speak. All right. So I move forward. So now I'll come to objects. So what are objects? You see, I'll not define what are objects because it will require some time to get the idea of what is an object. But you should understand that objects are the fundamental building blocks in Python. So most of the things which we'll use are objects in Python. All right. I should go on to say almost everything in Python is an object. All right. And objects has a type. So what is meant by type? You see, when I say cat, so cat is an object and this cat has some features like it can purr or it can jump, something like that. These features are called the features of that object and it is a type. All right. So whenever I say Luna, sorry, I was saying cat. So whenever I say Luna, which is the name of a cat, what is the type of Luna? It is a cat and this cat has some features. Similarly, when I say Sarah, who is a chef, the type of Sarah is chef. So she is a chef and this chef or Sarah has some features. What are the features? She can cook and create recipes or something like that. So everything in Python is an object and it has some, or it is of some type. So I'll show you some more examples in Python. So objects can be two types, scalar objects and non-scalar objects. When we talk about scalar objects, these are those objects which are in the most simplified form. It cannot be subdivided further. For example, an integer object. When we say an integer object, you see, you can have anything from minus infinity to plus infinity. Obviously it should be a number, you cannot write minus infinity, excluding minus infinity and plus infinity, and not having a decimal point in it. So it will be an integer, and you cannot divide this object any further, it is not subdivided. Similarly, a float. So what is a float? Actually, in programming language, any number which has a decimal point is called as floating point number. And why the name is given floating point number? You see, this decimal point can come here also 31.4, or it can come 314.0, or it can also be 0.314. So this point is actually floating. That is why it is known as floating point number. It is not important, but I wanted to tell you. That's why I have told you. So another scalar object is float or floating point numbers. Another scalar object is bool. Bool is actually boolean. So it will always have two values. Either it will be true or it will be false. And please note that I have written true with T capital and false with F capital, because that is how Python sees. If you come here and when you write true, you see TRUE, the color changes, and whenever the color changes, then you should know, then Python is recognizing it as something. What it is recognizing it, you should know that it is a keyword. All right, when you run this, you see you will get a true value. But if you write a small TRUE, the color will not change, and when you execute it, it will give an error. Name true is not defined. All right, so the T is capital and F is capital. There is also one more type, which is none type. This is generally not seen in many other languages. So what is none? None just denotes a missing value or undefined value in Python. So when you write none, it will also come in green color, none. You see, none value. All right. What are non-scalar objects? So these are all scalar objects which cannot be divided any further. Non-scalar objects are just compound objects. You take scalar objects and you aggregate it, and then you will get a non-scalar objects. So these are just data structures with internal complexity, such as lists. We will in my subsequent classes we will see what are lists, dictionaries, sets, tuples, etc. All right, allowing storage and manipulation of multiple elements. So these data structures can be divided, can be manipulated. Does anyone want to speak? All right, so these are non-scalar objects. These are formed by using these scalar objects. All right, so let me go. Now we will move on to other concepts using IPNB file. So any doubt till here? All right, so let us
No,
move.
sir.
All right, so let us move forward. So I have created one file here. I have written some text. So how have I written this text? Using the Markdown cell. All right, so I have written Markdown cells, and therefore I have written some text, and I'll share this file with you after the class so that you can read it. All right, so I am saying data types. So you see, I have said that each object has a type. So suppose if I come here and come to this and I write, see, true is there, and when you write type, so type is a actually function which says what type the variable or anything value which you are putting inside the curly braces, which is known as parenthesis in programming. It will tell the type of that thing. See, it is saying bool, so it is a boolean. When you say type in none, type, then it will say none type. So I have written, see, none type. All right, similarly when you write type for a number 2, so it will give int, and for float. All right, so I'll write it here as well again so that I can share it with you. So a data type in Python defines the type of data a variable can hold. So what is a variable? I have not come to it yet. All right, such as integers, floating point numbers, or text. I should not write text, I should write integers, or maybe write text, doesn't matter. And it dictates how operators can be performed on that data. So whatever the type of that object is, that will govern what operators will be used with that variable or that data. So if it is an integer type variable, or sorry, if it is an integer type object, then arithmetic operator will be applied to those operators. If it is some other like boolean, then logical operator will be applied to those data types. We will see today in this class. If you are not understanding what I'm saying, all right, just understand this, that each object has a type, and that type defines what operations can be done with that object. All right, and we can always use type to see what is the type of an object, and also a function called isInstance, which will check if that object is of a particular type. I'll give one example, then you will understand. First, let us proceed with numbers. All right. So what are numbers? Numbers can be integers, floating point numbers, as well as complex numbers. So you can write complex numbers in Python. If you are from a science background, so you will know what a complex number is. All right. So let me write a equals to 25. So you see I'm using variables, but till now I have not defined what a variable is. So please just see what I'm doing. All right. So when I say a equals to 25, the value of 25 is being assigned to a. All right, so this equal to is not the same equal to as that which we see in maths. In maths, we find the value of x using an equation where we have an equal to sign, but that equals to is not the same equal to over here. This equal to suggests an assignment. Assignment means this 25 value is been assigned to a, which is a variable. All right. Now if you write, let me just execute it. So it will be a equals to 25 is assigned to a, and when you write type a, when you check, so it is an int. All right. So I am just typing shift in enter, but I should type alt enter such that one cell will be inserted. Now what I am doing, I am saying a equals to 2.5. So you see earlier a was 25. It was implicit by Python that a is an integer. This is not the case when you write in Java or C++. In that you should define a to be an integer before you assign a value to a variable. But in Python you need not do that. Python is smart to understand what variable has what type. All right. So in line number 2, Python is assigning an integer value to a. Therefore, a is an integer object. All right. Please listen carefully. These are important terms which I am using. When I am saying a equals to 25, then Python is assigning an integer value to a. Thus, a becomes an integer object. All right. You can check when I am writing type a, it is saying that a is an integer object. Similarly, when I am writing a equals to 2.5, what is happening is a is reassigned a value of 2.5, and that 25 is lost in memory. We will take this in the end of the class. Just bear with me. All right. So when I'm saying a equals to 2.5, a value of 2.5 is assigned to a, and whatever was assigned earlier is lost in the memory. Now when you execute this and you check type type a, then you see you will get float. So now a is actually a floating point object. All right. Now you can say a is a complex number. So when you write a equals to 1 plus 2j, so j is used as imaginary, and when you execute this and when you check the type of a, you will get complex. So a is a complex number. All right. So these are numbers in Python. Now I also talked about a function which is isInstance. So you can check. So I am writing the code and you see if you are getting it. If not, then I'll tell you. So I'm running this. All right. So you see what it is doing. Can anybody tell what it is doing? I'll run one more code for better understanding. Yes, speak. I'm writing. No problem.
It's checking if A is a complex number or not and
No.
returning the statement.
Yes, it is returning a Boolean value. All right. So it will always return a Boolean value. So this is instant function always returns a Boolean value, either true or false. It will not return anything else. All right. So these functions check if a given value or an object is of a certain type or not. All right. Now we'll go to Booleans. So we have already seen what Boolean is, but still I'm going in the format I have written here. So Boolean represents truth value, either true or false. So when I say A equals to true, and we can check again what is the type A, then it says bool. Therefore, it is a Boolean object. Now, mind you, when I'm saying type A, it is giving an output, but it is not printing in the screen. So if you want to print the value of A in the screen, then you should always write print and give this inside print type A. And now you will get an output. All right, class Boolean. What is a class? We have not talked about. In subsequent lectures, we will always go to class and see what a class is. All right. So this is an this is you are printing in the screen, and this is an output. So you are just speaking into the value of type A. You're not printing and giving it to the end user. All right. When you are printing, you are giving this output to the end user. But when you are not printing, and this output suggests that it is just for you, the end user will not be able to see this output. All right. So you can always check this when you write a line below it. Suppose you are writing A equals to 5. When you're writing this, you see no output will come, because it will just give a sneak peek in the last line what is happening. All right. So when you erase this, you will see the output. I'm sorry. Yes. Now there is something called casting. So if you are familiar with any other language, you will know what a casting is. Casting is just conversion of one data type to another. So you are converting an object's data type. So suppose A is 10. Suppose A is 10. All right. So you can just check the type of A, what A is. So when you execute it, so you will see A is of type int. Now you can convert it to any other data type. Suppose you are converting it to float A. Now you can see it is 10.0, and if you see the type of this value, it will be float. All right. So this is casting. So you are casting one value to the other. You can also do that with some number. So these are variables. I'm using variables here. You can also do that with a number. Suppose you are doing 13.7, and when you change 13.7 to integer, it will give you a value of 13. It is just truncating the other part. All right. You can also do it with I have not talked about string. Let me show you str10. So str just converts a value to string. So what is a string? I have not talked about. Just bear with me. You see what a string is. A string is actually represented inside inverted commas. All right. And it is not a number. It is a alphabet. You can not alphabet, any character. It can be any character. All right. So it is not a number. You cannot operate it using arithmetic operator. So we'll come to string afterwards. Since I was talking about conversion, that's why I have given you this expression here. All right. Now we'll move on to operators. All right. So operators in Python are just symbols, unique symbols in a way, which means something and which can perform some operations on operands. So what is an operator and operand? So suppose when I was doing 2 plus 2, and when I was executing it, so 2 is an operand. Here 2 is an operand, but plus is an operator. It is an arithmetic operator. All right. So operators in Python are unique symbols used for performing arithmetic or logical operations. The data on which an operator acts is referred to as operands. All right. So there can be many types of operators. First can be arithmetic operator, comparison operator, logical operator, assignment operator, bitwise operator, and special operators which are specific to Python. So in today's class, I have planned to do 1, 2, 3, and 4. 5 and 6 we will see in later lectures. May not be tomorrow, but later lectures. All right. So first we'll see what is an arithmetic operator. So you see, arithmetic operators are often used to perform mathematical operations like addition, subtraction, multiplication, etc. You see, these are very simple concepts, but since I'm going in a flow, so I don't want to skip anything. That's why I'm mentioning everything here. All right. So when you use this plus, minus, multiplication, division, these are all arithmetic operations. So when I talk about other operators, at that point I will talk about arithmetic operators. First, let me come to expressions. All right. So I am not talking about arithmetic operators now. So what is an expression? Expression is actually we compose operators and operands together to create an expression. So when I was writing 2 plus 2, this is an expression, and expression will always have a value. Each expression yields a value which is of a specific data type. So when I do 2 plus 2 and when I execute it, we will get an output of 4. So this expression 2 plus 2, this is maths by the way. When 2 plus 2 is executed, or when 2 plus 2 is executed, then it will yield a value. The value is 4. More specifically, this value will be of a specific data type. You see, when you do 2 plus 2, you get a 4. But when you do 2 plus 2.0, you get 4.0. So this is of a specific data type. This is of another data type, and you can check it. How you can check it? You just add a cell below. I'm pressing this side and I'm pressing B. And when you do type 2 plus 2, and when you check, it will be int. But when you do type over here 2 plus 2.0 and I execute it, it will be float. All right. So this is an expression. Achha, is the lecture okay, or should I skip this parts? Is it not boring, right?
No.
Yeah,
All right.
it's okay.
Okay, sir.
All right. All right. So you see, I have just used one operator, addition. There can be many other operations. You just let me define x is equals to 10 maybe, and y is equals to 3. And let me go through all the arithmetic operators. Now x plus y, we have seen x plus y will be 13, x minus y will be 7. Now there is multiplication, which is x, and when you use this asterisk sign in programming, it says multiplication. So x into y is 30. Now you can also perform division. We have seen this in the earlier previously in this lecture only. So this is a backslash. So x by y, and it will yield 3.33. Now you have a special operator, which is this modulus sign. So if anybody know what this is, modulus, I am sure many of you would know. What is a modulus? X modulus y?
We'll get the reminder, sir.
Yes, it will give the remainder. So when you divide 10 by 3, you are getting 3 and then a remainder of 1. So it will give a remainder of 1. All right. I have already talked about this double backslash. It will actually give, not backslash, this is forward slash. I'm sorry. So x forward slash y. So it gives only the integer part of that expression and truncates everything else. All right. And there is one special arithmetic operator, double asterisk y. So can anybody say what is double asterisk y?
Power.
What it will do?
Power.
Power. Yes.
Exponential power.
Yes. It will be an exponential operator. It will give 10 to the power 3. All right. Now we will talk about operator precedence, and we know this by BODMAS. In school time we have done this. So let me just show you few of the things. So over here, that static semantics, not static semantics, semantics will come. So you see, when we go back, semantics will come. So you mean something, but you do something else. And this can happen when you don't know the precedence of the operators. So there are many types of operators we talked about. You see, there are arithmetic operators, comparison operator, logical operator. So you should know the precedence among all those. It is not just arithmetic operators precedence. So what we learned in school was the precedence in arithmetic operators, but there are other operators in programming as well, like comparison operator, logical operator, assignment operator. So you should know the precedence of among all these operators. So now we will see the precedence, operator's precedence. So since it is 7 o'clock now, so we can have a break of 5 minutes and then we will meet at 7:06. All right. All right. Thank
Okay.
you. So do come back. Huh? Yes. 7:06. Yes, I hope everybody is here. So can you confirm you are doing along with me or not? Because it will be better if you do along with me. In that case, you can stop me and you can also share your screen, and then I may clarify your errors or doubts maybe. So please do along with me as well. All right, you can just split your screen or do along with me.
Okay, sir.
Yeah,
Okay.
sure. So my screen is visible, right?
Yes.
Yes, sir.
Yes.
Yes.
All right, so I was in operator precedence. You see what I have written. Operator precedence defines the order in which operators are evaluated in expressions. Higher precedence, in which the operators have higher precedence and are evaluated first. Lower precedence are evaluated later. So just if we have 5 plus 3 into 2, so multiplication has a higher precedence. So it is evaluated first, which is 6, and then we add it to 5, which will be 11. All right. Suppose you have some ambiguity and you want 5 plus 3 first, so you should always give a parenthesis. So it will be 8 into 2, which is yield 16. All right. So we can see some precedence. So I'll write some expressions in arithmetic operators first. 5 plus 3 multiplied by 2. And in case you have any doubt and I have skipped some precedence, you can always do yourself and check. All right. So it may not be possible for me to write all the permutation and combinations of the operators and give you the precedence. So if you have any doubt, try yourself and see. It may give an error or not, it doesn't matter. You can always go back and check where the error is and what the precedence is. So always try yourself and check. All right. So you see you are getting 11. So you are getting 3 into 2 and plus 5. So it is 11. Now I just write something as 10 plus 5 into 2 minus 3 by 3. So it will be 3 by 3 will be evaluated, 5 into 2 will be evaluated, and then the addition and subtraction will be evaluated. All right. So this will yield 19. Someone is unmuted. Do you have any question? All right. Suppose you want the arithmetic operators to be operated first, so you can give a parenthesis. These are very simple mathematics. You can do like this and the precedence may change. All right. Now you see you have so we talked about some operators, but I have not given you the operators. So let's say there is a relational operator which we check in mathematics. So when we have an expression in mathematics, we check that if the right hand side is equal to the left hand side or not. So in that case, that equal to in mathematics states that the right hand side is equal to the left hand side. But in programming, we don't have such kind of operations. There can be a statement if you want to check if the right hand side and the left hand side is equal or not. What I mean, I will repeat. Suppose I want to check if the right hand side, which is 3 plus 7, is equal to 2 into 5 or not. All right. So in mathematics, you should write correctly. The left hand side should always be equal to the right hand side. But in programming, it works little bit differently. What you can do is you can check if the left hand side is equal to the right hand side or not. You can do that with double equal to sign. When you do double equal to sign, then you are asking a Boolean question. This is a Boolean expression. If the left hand side is equal to the right hand side or not. So you see this double equal to sign has the least precedence. So multiplication will also happen, addition will also happen. All those things will be evaluated, and at last this double equal to will be evaluated. All right. So you see it is true. So this is 10 and this is 10 and it is saying that it is true. But I would suggest if you are doing such kind of operations, always give a let me write it again. So when I give you the code, then it will be better for you. So whenever you have such kind of comparison, always give a parenthesis. In that case, you will not make a mistake in semantics. All right. You will always be correct and you will know what you want. So this is what it is. Now there is a logical operator called AND. So in Python, when you want to have a AND, so what is AND and what is What is and what is or you will know. So in other programming language you write and like this, but in Python you write and like this. All right, these are logical operators. What are logical operators? I'll come to it in a little bit, but you see, when I write logical operators, it also has the least precedence. All right, so it also checks. So what should I do? I should tell you a logical operator or not. Okay, let me write it first. When I say 5 is greater than equals to 3, sorry, 5 is greater than equals to 3. So this is a Boolean expression. All right, it is checking whether 5 is greater than equals to 3 or not. So let me execute it first. So it is saying true. Now you want to check if 10 is greater than equals to 20, greater than 20 or not. So you see, when you execute this, then it is false. 10 is not greater than equals to 20. Now you want to check if both the statements are true or false. So you want to check this and this. All right. Now when you do this, this and will be executed at last, whether you give parenthesis or not. I'll show you. All right. So this is true and this is false. And how and works, I will give you the working of and in a later bit. Just see that this and has the least precedence. This is evaluated first, then this is evaluated. These two are evaluated simultaneously, and at last and is evaluated. All right. So even if you don't give the parenthesis, it should work. I hope so. I hope so. It should work. Yes. So it is working. All right. So these are some of the precedents. If you have any doubt in some kind of precedents, just run some code, and by running the code you will learn. All right. So if I have missed obviously I have missed some of the operators. So you should write the operators and see the precedents. And if you want a comprehensive description of all the precedents, you should refer the book which I have suggested. In that book there is the list of precedents. But if there is any confusion, use parenthesis. That is the best advice I can give you at this point of time. Use parenthesis. All right. Now assignment, I have talked about assignment. You see, what is assignment? Assigning value to a variable. So when I'm saying a equals to 10, so this value 10 is being assigned to a. All right. So this equal to is an assignment, and what is it is saying? Using the equal to sign assigns a value to a variable name. That is what I have said. So for example, when I say, let me write this example. So c is the speed of light, which is actually 299,792,458. So this is the value of c. All right. So what is happening in memory? You see, this value 299,792,456 is there in the memory somewhere, and the value, this value, wherever it is there, that is having an index or an address. So suppose there are some cells in the memory, some vacant positions in the memory. So this value will be stored in that memory location. So suppose that location ID is what is location ID? You see, whenever you store a data, suppose this is a data 299,792,458. So it will be stored somewhere in the memory, and wherever it will be stored, the address of that memory is called location ID, and this C will point to that ID. So what it is doing, this C is actually pointing to that ID. So this assignment is actually giving the address of this data which is stored in the memory and assigning that value to C. If it is not clear, just bear with me with 3-4 lines of code and it will be clear when we go forward. All right. If it is not clear, otherwise it's okay. All right. So just think this value is assigned to C using the operator equal to. Now I am saying this speed of light is this and time it is 2 seconds. Now I want to calculate distance traveled. So distance TRAVEL, distance travel will be times speed times the time. So time into speed. So this will give me the value. All right. So why it is not giving me a value? First of all, because the last line is being executed, and what the last line is doing is it is evaluating this expression and assigning that value to this variable. So if you want to get the value of this variable, you should write in the, you should write it here and then evaluate. So what did I do? Did you understand why this did not give us output? If I was unclear, I am repeating it again. Okay. So there are three assignments actually. This value is assigned to C, this value is assigned to time, and whatever this is being evaluated, it is assigned to distance traveled. But we are not saying a print distance traveled. So we are saying it in this line. That's why we are getting an output and we are not getting an output in this line. All right. So this is the value of output. One more thing, you see the precedence. I have given this multiplied by this. So this variable is multiplied by this, then the precedence of equal to comes. Only the expression, this side, the right hand side expression is evaluated. Only when it is evaluated, then that value is being assigned to distance traveled, not earlier. All right. So this assignment operator has the least precedence. Always everything will be evaluated this side, all the things, a logical operator also, and or everything will be evaluated, and then the precedence of equal to comes, and then it is assigned to the right hand side. All right. So we have got the value of distance traveled. Is everything clear? Because I talked a lot. I don't know if it was clear.
Yes, sir, it's clear.
Yeah, it's clear.
All right. So now I also told you what is the difference between mathematics and programming. When I say x is equals to 2, we are assigning the value of 2 to x and not mathematics. All right. So this we have already talked about. Now we will come to variable binding. All right. So this is what I was talking about when I was saying ID, location ID or something like that. So let me go back to the slides, and when I come here, so this is what is happening. You see, this purple area is the memory of the computer. All right. And this value 299792458 is in some location in the memory, and it will have some ID. All right. It will have some ID. You can check the ID, by the way. Let me go back and show you. It is there, by the way. Again, you can check ID bracket, and if you write C, you will get a value. You get this value. So what is this actually? This is the value of the, not value, this is the variable where it is stored, the location's ID, or that is what it is, the location's ID. So this value is stored in this location 140220085395056. So that is the location of this position, and this value 299792458 is stored in that location. And this assignment is what assignment is doing. When we say C is equals to this, it is pointing this variable to that value or that location. All right. Similarly, time is pointing to 2. You see, we have given time is equals to 2. So 2 is being stored in some location. You can check what is the ID of 2. So ID of time is, you can always check, this is the ID of time. So not time, sorry, ID of the location at which 2 is stored. All right. So 2 is stored in this location. All right. And time is pointing to that location. Similarly, when you evaluate these two and you get a value, that value is stored in the memory, and distance travel points to that location. All right. Is it clear?
Yes, sir.
Yes, sir. Yeah.
If anybody has doubt, please stop me, because this is important. Why is this important? Because when you change some variable's value, then what is happening inside the memory you should know. Otherwise, you will write a buggy code. All right. So these concepts are very basic, and you should know what is happening behind the curtain, you can say. All right. So if anybody has a slightest of doubt, please stop me and ask. What is ID? What is location? Anything, any doubt? All clear? All right. So I will change one thing now. All right. So you see what we did. We did, just a minute. Yes. So I will just copy this again for convenience, and I'll write here. All right, just I'll write here. Before that, let me see what I have written. So rebinding, variable name can be assigned to a new just I'll do that. So you see I have just written the same code which I have written earlier, and I'll run it. All right. So for getting the value of distance, I will copy it and write it here such that I'll get the value of distance. So this cell is clear to everyone? This cell is
Yes,
clear?
sir.
Yes. Now what I'm doing is I'm assigning a value of 7 to time. So I'm saying time was not 2. Let the time be 7. So you see I have changed the value of time. So what should be the value of distance traveled? Can anybody tell me what should be the value of distance traveled now? Make this, let me make this easy. Suppose C is 20.
1996, the Kerala government.
So C, I made C as 20, although it's not correct, let it be. So let me make this speed, otherwise I am writing wrong. Okay, so speed is 20, and again I am changing time to 7. So what will be the value of distance traveled? Can anybody tell me?
140.
140. Any other answer? So the confusion is actually in 40 and 140. Either it will be 40, either it or it will be 140. So how many of you say that it will be 140? And how many of you say it will be 40? And why? No, you can speak because I'm not seeing the screen of the video. You can unmute yourself. So how many of you want to say it is 140?
140.
140, sir.
140. And how many of you want to say it is 40? All right, so let me clear that out. I couldn't get the vote actually. So first let me execute it. You see, the value is 40 and not 140. Why is it so? You see, computers are stupid. Actually, they are stupid. They don't know anything in their own. They only do whatever you tell them to do. All right, so you have, and one more thing, the execution happens line by line. In yesterday's class, someone asked this question. So the interpreter, what is an interpreter? I'll tell you, just give me 1 minute. And if I forget, please remind me. Huh? So the interpreter actually goes line by line. It comes to this line, then it goes to this line, then it goes to this line, then this line, then this line, and then this line. All right. The interpreter is going one by one. It is not going back. It will always go in a step-by-step format. It can always jump if you have some other function calling other function, then it will jump, but it will act in your instruction. Whatever you instruct in the sequence, it will do in that sequence only. All right. Second thing, you see, we had drawn this figure. Now, if I give you this figure, this is what is happening. You see, distance was always pointing to this value 599. Let me change this value, it will be better so that you can follow it afterwards. All right, so the distance was always pointing to this value 599,584,916. What we did, we changed the pointer to this value. So time was, we changed time to 7. So this assignment, what it did is it gave the ID of 7 to time, and this time is actually pointing to 7, but we never changed the value of distance traveled. Therefore distance traveled did not change. If you want to change the distance traveled, then you have to run this code again. Whenever you run this code again and then you check for distance traveled, then you will have a changed value of distance traveled. All right, you see, distance traveled value change. So is it clear?
Yes, sir. Yes.
So everybody who was saying 140, is the doubt clear? Because it is important. Actually, this is important.
Yes. Yes.
Rajiv was saying maybe 140. Rajiv, is it clear?
Sir. Yeah. Now it's clear.
All right. So this is what variable binding is. So now I will read, it will make sense. What is rebinding? Variable name can be reassigned using new assignment statements. So I'm reassigning this value to a variable name. Memory retention. The previous value may still be there in the memory, but is no longer accessible. You see, this value 2 is actually there in the memory, and we are not able to, grasp that value again. It is not possible to grasp that value again once it's lost. But it is not erased. It is still there in the memory. There is something called garbage collector in Python. It collects the garbage and deletes it. That is not what we are talking about. But this value is still there in the memory and it is not erased. This is also important to know. All right. Calculation control, the value of an expression like distance traveled remains constant until the computer is instructed to recompute it. This is what I have done when I am executing this cell 64. All right. All right.
Yes, sir.
Yes. Now I will play with this thing a little bit more. All right. So you see, when I say x is equals to 34 and I execute this, sorry, I have to get the ID as well. So ID of x, ID of x. So it will give me one for some random number, which is actually the location of this 34. All right. Now when I say y is equals to 34, and again I write the ID of y. So before I execute this line, should this ID be same as this value or should this ID be of different value? What do you say?
Different.
Different one.
Why different value?
It's a different variable now. So
Yes, the variable is different. You're correct.
so the location should also be different, means like, yeah.
No, you are actually wrong. You see, we talked about numbers. So in Python, there is numbers. So whenever you write a number and in the memory, I mean to say whenever you give a number in the memory to store in the memory, then it is stored in some specific location. All right, let me come. Yeah. So, yeah. So it is stored in some specific location. And whenever you assign that value to a variable, this pointing happens. So this 2 is assigned in the memory somewhere. And whenever you assign this value 2 to a variable, that variable will point to that value 2. So when I say ID y, you see the same ID will be assigned in the same both the cases. All right. Is it clear or is it confusing?
So you mean to say that for any given value along the entire program there will be one location, and that location will be that ID will be shared across different variables.
Yes, only if the kernel is same. So you see, if kernel is a mini computer, so you just write this value or just memorize this value 14022 something like that. The last is 0096. All right, I'm restarting the kernel. All right, restarting and run all. This number will change.
Okay.
Just let me see, just memorize this 196. It has executed and you see the number has changed 35600. So for each execution, the memory is refreshed, you can say, and those are lost. And now you have a new ID for this value. All right.
Yeah, got it.
Is the session becoming heavy? If it is becoming heavy, you can tell me. I can stop at any time. I can take the other things in the next class. Should I
No,
continue?
yeah, it's okay for me.
All right. Now again you see, when you say z is equals to x, when you are saying z is equals to x and checking the ID of z, ID of z, what will be the ID of z, same or different?
Same.
Same.
Same. All right. Now one interesting thing to note, this is not important in Python, but I am telling you, suppose you are saying that z is equals to 35, one more than 34. All right. And when you get the ID of this, when you get the ID of z and you execute it, you see it is 32 more than the previous one, exactly 32, right?
Yes.
So each location in memory where a value is assigned is of 32 bit. That is, integer values occupies 32 bits in memory. So what is bit and byte? If you don't know, I can take some time and explain, but it will be outside our course curriculum or syllabus or scope, you can say. All right, so integer is assigned 32 bit in memory. All right, so you can check 100 minus 101 minus 1. When you do this and you say 101 minus 1 is 100, and when you say type and divide this by 32, one more bracket should be there. Just give me 1 minute. One more bracket should be here, and I am dividing it by 32. So it will, sorry, not type, ID. I'm sorry. No, what am I doing? I am doing, okay, what I wanted to do is 101. So I want the ID of 101. All right. I want the ID of 101. So this is the ID of 101. I want the ID of 1. So when I get the ID of 1, so this is this. Now when you subtract this value minus this value minus this value, and when you divide it by 32, because each value is taking 32 bit, so this should be 100. This should be 100, right? It is coming to 100. So 1 and 101 is has a gap of 100, and each bit is taking 32 bits. That's why the ID location for these two when divided by 32 gives 100. Is it all right?
So even though we didn't use or we didn't assign like 20, 21, 22, but the location for this 20, 21, 22 are already predefined in the memory, is it?
Yes, it is in sequence. So that is how a computer actually stores data in memory.
So is there any limit for this? I mean, the maximum number or something?
So the data which it will store will depend upon the memory of your computer.
Okay.
Okay.
All right. So it can also randomly change. So suppose you want from 1 to 100, or you want 1 lakh to uh, after that. So it will randomly change. It can just erase. So I told you something called garbage. What I told you? Uh, I forgot. Yeah. So there is
Garbage
something.
collector.
Yeah, garbage collector. So it collects garbage and just erases it in the memory. All right. So whenever I change the kernel, these locations will change randomly. All right. Is it okay? Or should I take 1 or 2 examples more?
Okay.
Right. So let us go to comparison operator. So we have seen arithmetic operators. So when I was talking about arithmetic operators, we had seen, no, this is not arithmetic operator. This is arithmetic operator. Expression. So we talked about plus, minus, multiplication, division, modulus. This is integer division, and power. So arithmetic operator we have talked about. We can talk about comparison operator. So in comparison operator, we have greater than equals to, less than equals to, double equal to, which is checking if the right hand side expression and the left hand side expression is the same or not. This is not equal to, this is greater than equals to, this is less than equals to. These are comparison operators. All right. So you can just say A is equals to 20 and B is equals to 7, something, any value you can take. All right. And then you can say is A less than equals to B. You can just check false. If A is greater than equals to B, you can just check true. The other is A double equals to B. You can check false. Is A not equals to B? So it will be true because A is not equals to B, or because 2 is not equals to 7. Now is A greater than will this work? I don't know. Let me check. No. Yes, it is true. Is A less than equals to B? False. Everything is done, I guess. Yes. So these are comparison operators. All right. Is it okay?
Yes.
Now we have logical operators. So logical and, or, and not. So how many of you have idea of and, or, and not? If not, then I have to go in a little bit of details. So do you know what is logical and, logical or, and logical not?
No.
No. All right, then I have to go to the net because I have not made that slide. Logical and, or table. Yes. So let me see if I can. So is this visible or?
Yeah, it's visible.
Yeah.
Yes.
So you see, we are not talking about XOR right now. We are talking about and, or, and not. So what is and? And is just a multiplication, you can say. Actually, you see, computers have only two binary representation, either 0 or 1. So 0 is actually off and 1 is actually on. So if I go in little bit of computer science, you see, in general life, we count in decimals. So we have 10 digits. In binary, you have only two digits, either 0 or 1. And how do computers check if it is 0 or 1? It checks via electricity. So if electricity is flowing through the circuit, then it is 1. And if the electricity is not flowing through the circuit, then it will be 0. All right. And these are checked and, or, not. These are checked using transistors. So this, we are going into electronics, so it will be difficult for many of you, so I'll not go any further. So you just understand that if in a circuit electricity is flowing, the computer interprets it as 1, and when the electricity or current is not flowing, I should say current, I'm sorry, I'm an engineer and I'm saying wrong terms. If the current is not flowing, then it is 0. Yes. So what I was saying, interpretation. Yes. So you see, when you have some advertisement of some CPUs in the market, like Apple announced M1 chip, M2 chip, you see they say that there are billions and billions of transistors in their chip, and each transistors are performing some operations, and the data is being read by using these digits only, 0 and 1. All right. So this is just an overview how data is being represented. If I go back to the previous lecture slides, and this is my lecture 1 slides. Let me go back to inputs and outputs. You see, we talked about in this slide, yeah, we talked about the black box. What is in the black box yesterday? But we did not talk about the input and output. A little bit we talked about, but we did not talk what is the representation of input and output. You see, whenever you give an input to a computer, it will not understand. You see, you are saying something in English because we are writing the code also in English. All these things are in English. You see, where is the code? This is the code. So we are saying A less than B, or everything is in some programming language or English or something like that, but it is not in the machine language. So the input to the computer is this, not computer, yeah, you can say the computer, but it is converted to machine language using an interpreter, and it converts this code to a machine code which is actually in zeros and ones. It will only be in zeros and ones, and then only the computer will understand. All right. So this is just a brief description of computer science, and if you have not understood anything, doesn't matter, we will not go there at all. All right. So whenever you say 0, it is in Python we can also say as false, and whenever you say 1 in Python you can also say as true. So true value is represented as 1 and false value is represented as 0. So and is actually a multiplication, you can say. So 0 into 0 is always 0, 0 into 1 is 0, 1 into 0 is 0, and 1 into 1 is 1. Mind you, it is not exactly multiplication. For simplicity I am saying multiplication. All right, it is not just multiplication. A lot of things is going on when we are saying AND operator behind the scene. Similarly, OR operator, it is addition. So 0 plus 0 it is 0, 0 plus 1 is 1, 1 plus 0 is 1. 1 plus 1 is not 2, it is also 1. Alright, so true and not true or true. So either this is true or this is true. So it will evaluate to true. So these are evaluation of these two. So when x is 0 and y is 0, x plus y or x or y will be 0. You can understand this using simple English. Suppose you are saying false or false, so it will be false. Whenever you say false or true, so it will always give precedence to false, so it will be, sorry, or will give precedence to true, so it will be true. True or false, it will be true. True or true, it will be true. And will always give precedence to false, so it will be false and false, false, false and true, false, true and false, false, true and true, true. Alright, so this is and or. There is one more thing, not. So this is actually complementation. So whatever will be the value, it will just complement it. It will change it. It will change the bit. So if the bit is 0, it will change it to 1. And if the bit is 1, it will change it to 0. Alright. So did I make sense, or was I speaking gibberish? Hello?
It's okay, sir. It's fine.
Alright. So someone was telling that they don't know about and or. So did you understood what is and or and not?
Yes, sir.
Yes.
Yeah.
Okay, so when you say A equals to true, sorry, TRUE true, and B equals to, let me say, false, you can take anything, just for explanation I am taking. And you have three operators, A and B. So this will evaluate to the same thing which we saw in the table. So this is true and this is false. You can go back to the table and see this is true and this is false. It will evaluate to false. Let us check whether it is evaluating to false or not. You see false. All right. Similarly, you can do many things. You can change, sorry, A and B. You can change this false and true and you can play around. You will always get the same table back. You can see A or B. It will evaluate to true. You can also do not B. It will evaluate to true because B was false and it evaluated to true. All right. So these are some of the logical operator. We can use it in conditionals. So if you have condition, you say A is some condition which will evaluate to either true or false, and B, not condition, sorry, it is an expression or Boolean expression which will either evaluate to true or false, and B is also an expression which will either evaluate to true and false, and we are checking if both of them are true or not. If you go back to my previous slide and you can see here when we were talking about, you had this words. So if this statement, this was a Boolean expression, if else if this statement, this was also a Boolean expression. All right, this will either evaluate to true or false. All right, again you did this and you had another Boolean expression and you want to check both of them should be true. So you can see one example. Suppose you are checking if a marks of a student is in between some range. So suppose the marks is MARKS, marks is 50, and you want to check if, though we have not talked about conditionals, let me write it. If marks MARKS, marks is greater than 40 and marks is less than 60, you want to check this. All right, so whatever I'm doing, you may not know or you may also know, but I want to give you one point, that's why I'm writing it here. Print marks in between range. All right, marks in between range. So when you execute this, you see this is executed. Why? Because this is true, marks is greater than 40 and marks is greater than 60, sorry, less than 60. So this is true and therefore I have indented it. It means that whatever is, if this if block is true, then whatever is here you have to execute it. So it is executed. Marks is in between range. All right, I hope it was not difficult. Should I proceed?
Yes.
Yes.
So today, this is the last thing of today's lecture, assignment operator. And you have seen only one operator, equal to, but there are many more assignment operators in Python. All right, or many other languages also. Java has also some of the this assignment operators. You see, we have seen a is equals to 5. We have seen this already. And when you have to print a, you should write a. Otherwise, the value will not come. All right. So a equals to 5. Another thing you can do is a plus equal to 5. So if others have this idea of other languages, then you always know, you can know what the value will be. So if you have an idea what this will do, you can say. Otherwise, I will explain.
Will be 10 add to the existing value.
It will be 10. Yes. So what it does is, this expression actually means that what does this mean? First, let me tell you. This says that actually a is equals to a plus 5. This expression is same as this expression. All right. This says that a equals to a plus 5. You should read this in this way. All right. And I forgot to mention you this, that if you want to comment any line in Python, you just have to press hash and it will be a comment. All right. So when you evaluate this, it will be 10 because a was 5 and we add 5, so it become 10. All right. So you can do the other expression also, a minus equals to 5, which will always be a is equals to a minus 5. So a was 10, now you are subtracting 5, so the value will be 5. All right. Now the other expression is divide. So a divide by equals to 5. So a is actually 5, and this expression actually means, let me write it for simplicity, a by 5. All right, and let me comment it. And if you want to comment some code, command /, it will change to comment and uncomment, comment uncomment. All right, command /. Now if you check a, it will be 1. It should be 1, I guess. Yes, it is 1. All right. Now if you have, again, let me define a first. A is something 13. All right, and you want to do a modulus equals to 2. So what is this? It is a equals to a mod 2. All right. So this is what it is, and it will give you a remainder of 1, because when you divide 13 by 2, the remainder is 1, so it is 1. All right. Another thing you can do is a, let me assign a by again 13. Now you are doing a double / equal to 2. So this is same as a equals to a double back / 2. All right, I will comment this and it will evaluate to 6. Yes, it is evaluating to 6 and not 6.5. If anybody has doubt, you can please stop me and ask. All right. Now I am saying a double asterisk equal to 2. This means a equals to a to the power double asterisk 2, which will evaluate to 2, which will evaluate to 6 to the power 2, which is 36. And the last, no, I have completed all. Yeah. So this was the last. No, oh, there are other also, and equal to, not equal to. These are all you can check. All right. So this is for today's class. Any doubt? Hello. Any doubt?
Yes, Bhaiya.
Yes.
Hello, Bhaiya.
Yes.
H we are like putting a equal to means 5, and then h plus equal to 5, then that is giving an output of h equal to 10.
Yes.
Then if we'll put like a equal to plus 5, then it's showing error kind of. Then what does this
A
mean?
plus equal to 5. It is not the other
Yeah,
way
like,
around.
sorry.
It is a plus equal to 5, not a equal to plus 5.
So means it's going means step by step, means first adding and then equal to.
Yes, yes, yes. That is what we have learned when we were talking about operator precedence. It will always add first. You see, this is different from mathematics. there are two A's here, and this is always an incorrect statement in mathematics. You cannot have A equal to A plus 5. But this is not mathematics. What it is doing, it is first evaluating this expression. You see, we have talked about this when we were talking about operator precedence. It will evaluate A plus 5 first, and then it will assign A plus 5 to A again. All right?
Okay, yeah.
All right. Any questions? Just please be here. Yeah, your hand is up, Dr. A. Kalibani. Do you have any doubt? All right, so please be here. I have to take the attendance. I hope so you don't have any doubt. All right, so before that, in yesterday's class, I forgot to mention the reference. So yesterday's class was highly inspired by the lectures of Harvard University, Introduction to Computer Science, CS50. This is a very good course on computer science. All right, and today's reference is MIT's course 6001, Introduction to Computer Science and Programming in Python. This is an MIT open coursework course, and it was offered in 2016. All right. Thank you. Just wait. Some people are leaving, so it's difficult for me to take the attendance. So if you can see my screen, please tell your serial number, and I will mark your attendance. So I guess all the names are not visible. So please tell one by one. Rajiv is there, no? If you can see your name, please tell me the number.
24.
Yeah, one by one.
31.
31.
30.
Yes.
33.
33 I have done. 32. Yes.
34.
34. Others?
Hello.
Yes.
Yes, sir. My name is Nilima Kollare, but where is the number?
25. 25.
Okay, sir.
So you have written NEELIMA in the Google form.
Yes, sir.
Okay, and you are joining here as NILIMA. That's why I
Yes,
was.
officially. Yes, sir. Officially NEELIMA.
Okay. Okay. Anyone else? I saw 12 or 14 participants, but only 1, 2, 4, 5, 6 participants are giving attendance.
35. Can you hear me?
Yes, it's 35. Yeah. Anyone else? I'll see the attendance sheet after the meeting, then it will be clear. But it will be difficult for me to check it after every class. All right. And did I leave anyone else? How many are present? 1, 2, 7. No? Ashok Vardhan is here, but he is not responding. Okay, I'll check it afterwards. Thank you. So do you have any doubt?
No.
Okay, thanks for joining. So I'll leave them, end the meeting. I'll upload all the lectures in the platform. All right.
Thank you.
Thank you.
Thank you, sir.
Thank you. Thank you, sir.
Thank you.